we left off. We were in 1110. And I'm going to remind you of kind of where we ended last time. Maybe kind of give you a summation of what we talked about. So what we wanted to do, we wanted to find a power series representation for any function f of x. Any function. Okay. And so what we did is we said, okay, let's say f of x has a power series representation, C0, C1, x minus a, centered at a. And we needed to find the coefficients C0, C1, C2, and so forth. So we went through a process last time on how to find those coefficients. We plugged in a and we took derivatives. And so to sum up what we noticed last time, we saw that these coefficients Cn, we gave a formula for them, and it was the nth derivative of f, I plug in a, over n factorial. And I think this is where we left off. So what I can do now is I have a general formula for my power series representation. So our power series representation, it's Cn x minus a to the n, because I'm centered at a. And now I'm going to plug in my formula for my coefficients. It's f, the nth derivative, over n factorial, x minus a to the n. So this right here, this is the power series representation we were looking for. This part right here. And if you wanted to, let's write out a few of these terms so we can see what this power series looks like. Our constant term is fa, f prime of a over 1 factorial, x minus a, plus f double prime, plug in a, over 2 factorial, x minus a squared, and so forth. And this is what we call a Taylor series. This up here is called a Taylor series of your function f of x centered at a or centered at a, either one. Okay. So we've answered our overall question. I have a function. I want to know how to write a power series representation of that. And now I know. I have a formula. It's kind of complicated looking, but I have a formula for how to find it. Now, I do want to tell you, if you're taking the Taylor series at 0, so if a equals 0, your formula looks a little bit nicer. You plug in a equals 0, and this just becomes x to the n. This is what's called a Maclaurin series. Okay. So really, a Maclaurin series is just a special case of a Taylor series. In practice, a lot of times we take A equals 0, and so they decided to give that a special name. They call it the Maclaurin series.